The aim of this video is to do item 3. In the 15-day Tour de Moravia, let's ignore this extra E, Moravia, the cyclist must ride 120 kilometers on the first day, and each successive day they ride 90% of the distance of the previous day. Part A. How far do they ride in total to the nearest kilometer? So firstly, I know it carries on for 15 days, and I know it starts off 120 kilometers. So when I start here with part A, I can say that term 1 is 120. Then I find a very important piece of information is that they ride 9% of the distance of the previous day. So I can work out term 2. Now term 2 is 120 times 90%. Now 90% means 90 over 100. If you work that out, you'll get 108. If you continue with this pattern and work out term 3, you need to go 108 times 90%, which is 108 times 90 over 100, and you should get 97.2. Then you can check that when I go term 3 divide by term 2, you'll get an answer of 0.9. The same happens when I divide term 2 and term 1. Because I get 0.9, I now know it's geometric. I know A, which is the first term, is 120, and I also know R is the 0.9. I also know I want this to continue for 15 days, so N must be 15. I want to add up the distances I travelled each day, that's why we'll use Sn. So I'll use the formula Sn equal A bracket 1 minus R to the N over 1 minus R. Now you substitute, A is 120, bracket 1 take R is 0.9, then to the power of 15, make sure the 15 is inside the bracket, and the denominator is 1 minus 0.9. You can work that out on a calculator, and you will get 952.931 kilometers. So that's how far you will ride in total, and if I round now to the nearest kilometer, you know it's 953 kilometers over the 15 days. Part B. After how many days, so the important thing is how many days, well, they've ridden half of that distance. So then I have to start part B by halving the 953. So 953 divided by 2 gives you 476.5. Now, because it's after how many days I would have written that, it's still the Sn formula. That's the total I'm looking for. So I'm looking for Sn 476.5. A is still 120. R is still 0.9, but it's the N that I do not know. So I substitute into the formula Sn equal A bracket 1 minus R to the N, everything over 1 minus R. Sn is 476.5, A is 120, 1 minus R is 0.9, N is unknown, and then 1 minus R, and R is 0.9. Now 1 minus 0.9 is 0.1, so I'll get 476.5 equal 120 bracket 1 minus 0.9 to the N over 0.1. So 120 divided by 0.1 is 1,200. So I get 1,200 and then this bracket. And the next step is I'll divide by the 1,200 on both sides. So it cancels on the right hand side. And then to finish it off, to rearrange, I will add 0.9n to the left hand side to cancel it on the right, and subtract that fraction from both sides to cancel it on the left. Now you would have to take your calculator and work out that decimal. And that decimal is the following. So you get 0.9 to the power n is approximately 0.6029. Now I have to guess and check. I'll do it in this final space here. Let's say you try to the power 4, So if I go 0.9 to the 4, you get 0.6561. If I go to the power of 5, so it was too big, the power of 5 is 0.59049. Aha, that is just underneath the value I'm looking for. So that means n must equal 5. Therefore, after 5 days, you will have driven half the distance. Half of the total distance over the 15 days. Thank you.